All right, welcome to The Explainer. Today, we've got a truly fascinating historical history on our hands. We're going to look at the ancient history of South Asia. It's a region with this incredibly rich, complex past that has literally puzzled researchers for decades. Okay, let's dive into this. Just imagine trying to piece together the story of a massive, super sophisticated society, but they left behind zero readable books, no grand monuments with decipherable inscriptions, no historical records as we know them today. So how do you uncover their secrets? Well, the answer isn't in a library. It's actually in the very bones and DNA of the people who live there.
Here's our roadmap for today's explainer. We'll start by unearthing ancient South Asia, then look at the tools of the trade. After that, we'll examine the isotope evidence and the secrets unlocked by ancient DNA. Finally, we'll track ancient gene flows to see exactly how South Asia became a genetic melting pot.
Section 1. Unearthing Ancient South Asia.
To really grasp the magnitude of this scientific detective story, we first need to understand the society that left these clues behind, the Indus Valley civilization. And the geographic scale here, it's absolutely massive. Flourishing in the 3rd millennium BC, these settlements spanned a vast area across modern-day Pakistan and northwest India. You've got these massive, fertile alluvial plains of the Indus and Ghaggar-Hakra river systems, but they're flanked by resource-rich highlands to the west, north, and east. Now, because the plains lacked certain mineral wealth, the lowland folks had to establish sprawling trade networks with the highland communities. They built highly organized cities, standardized their weights and measures, and shared a surprisingly unified material culture over immense distances. Yet, their script remains totally undeciphered, which makes them a perfect scientific mystery.
Section 2. Tools of the Trade.
To solve a mystery with no written records, researchers have to look really closely at what the Earth preserved. Our guides for this explainer are the pioneering studies of researchers like Benjamin Thomas Valentine and Dr. Neeraj Rai, who use two beautifully complementary methods. Now, what's really interesting about this is how we actually get the data. On one side, we have isotopic analysis. By examining isotopes of strontium, lead, and oxygen in human tooth enamel, scientists like Benjamin Valentine can actually reconstruct a single individual's life history of mobility. It literally tells us where you were born and where you moved during your childhood. On the other side, we have ancient DNA analysis, utilized by Dr. Neeraj Rai. This doesn't just look at one lifetime. It reveals who your deep ancestors were thousands of years ago, tracking these vast generational shifts. Together, they give us both the micro and the macro story of human movement.
Section 3. The isotope evidence.
Let's look closely at what isotopes tell us about the day-to-day social fabric of the Indus Valley, specifically looking at their highly structured cemeteries. This data comes directly from Valentine's multi-site analysis, and the results are honestly shocking. If you look at urban centers like Harappa and the frontier town of Farmana during the civilization's zenith, the isotope signatures in the tooth enamel reveal that formal cemetery burials weren't just some mix of locals and travelers. They were reserved almost exclusively for immigrants. Let that sink in for a second. The individuals given these specific formal interments during the peak urban era were almost entirely people who had migrated to these cities from outside the local area, likely from those resource-rich highlands. By the post-urban era at sites like Sinali, this strict pattern began to fade into a lower, kind of more varying frequency of immigrants. And this brings us to what Valentine proposes as the all-immigrant hypothesis. The intra-individual isotopic data, which essentially acts like a timeline locked in a tooth, shows that these individuals didn't just move. They specifically migrated as young children. This suggests an incredibly complex social institution, possibly a system of fosterage. In this model, children from the highland communities were sent to live in the lowland urban centers. This wasn't necessarily a hostile displacement either. It was potentially a strategic way to build kinship, secure access to vital highland minerals, and forge lasting interregional trade alliances. To really conceptualize how the society functioned, researchers used the visual metaphor of a meshwork or a weave. The Indus civilization wasn't just distinct, isolated blocks of peoples statically trading goods. It was a dynamic, interconnected social fabric. Think of different cultural threads, highlanders and lowlanders, farmers and miners, crossing, tangling, and hybridizing. These child immigrants we see in the cemeteries essentially served as the physical knots in this weave, tying disparate regions together into a cohesive, sprawling civilization, all without the need for a heavily centralized, warmongering state.
Section 4. Unlocking ancient DNA. While isotopes tell us about the remarkable mobility of individuals within their own lifetimes, what does the broader genetic code tell us about deep ancestry? So the crucial point is this: who actually built the Indus Valley civilization? This is one of the most heavily debated, high-stakes historical questions in South Asian history. Were they indigenous populations? Did they arrive from elsewhere? By looking at the DNA preserved in the skeletal remains of these ancient individuals, science can finally provide objective data to begin answering these fundamental questions about human origins. The foundational baseline for understanding modern South Asian genetics involves two major ancestral components: ancestral North Indian, or ANI, and ancestral South Indian, or ASI. According to Dr. Rice reports, these lines deeply mixed between 4,000 and 2,000 years ago. The major takeaway from this genetic mapping is that today there is absolutely no such thing as pure ancestry. Every single population group in the region is a diverse genetic sandwich of these foundational lines. It's the result of thousands of years of continuous, multi-layered mixing.
Section 5. Tracking ancient gene flows.
To really understand the origins of the Indus people, we have to zoom out and look at the massive flow of human genes across the entire Eurasian continent over tens of thousands of years. Let's move to this and see how it builds. Looking at Dr. Rai's genetic timeline, we see modern humans migrating out of Africa around 100,000 years ago. Fast forward to 11,000 years ago, and we see an Iranian-related ancestry arriving in South Asia long before the advent of farming. Then, we hit the Indus Valley zenith around 2600 BC. Noticeably, according to data from sites like Rakhigarhi and Sonali, Central Asian steppe ancestry does not appear in the South Asian genetic record until roughly 1500 BC, well after the Indus urban peak. This timeline fundamentally challenges long-held theories regarding the arrival of Central Asian populations in the region.
Drilling down into specific discoveries, Dr. Rai's analysis of a woman from the Indus site of Rakhigarhi reveals a truly fascinating profile. Her DNA shows no steppe ancestry, which indicates the Harappan civilization was developed indigenously by local populations. The Iranian-related ancestry she possessed arrived 11,000 years ago, confirming that Indus agriculture was developed locally, not brought in by later Iranian farmers. Even more surprisingly, DNA from cemetery outliers in Central Asian sites like Gonor perfectly match the Rakhigarhi DNA. They were actually buried with Indus cultural artifacts, providing strong scientific evidence for an out-of-India migration happening over 4,500 years ago.
Section 6. A genetic melting pot.
These scientific tools don't just illuminate the ancient past, they prove that South Asia has never stopped being a dynamic hub of continuous human movement. Over the last 2,000 years, the genetic tapestry has been constantly rewoven by smaller, fascinating migrations. We see the cities arriving from Africa in the 14th and 15th centuries. Genetic data traces the Roma populations of Europe straight back to northwest India. The Parsis arriving in Gujarat preserved ancient Neolithic Iranian Zoroastrian roots better than populations remaining in Iran. The Ahoms arrived in the northeast, bringing Southeast Asian heritage. Cochinjus seamlessly blended into the coastal genetic fabric over dozens of generations. And up at the high-altitude Rupkund Lake, ancient DNA even revealed a mysterious group of 9th century travelers with distinct Greek ancestry who perished in the harsh climate. The movement simply never stops. This continuous blending brings us to a powerful conclusion, perfectly highlighted in a quote shared during Dr. Rai's presentation from scholar Thomas R. Troutman. He states, "Scientifically speaking, there are no such things as Aryan or Dravidian races. Biologically, both the North and South Indians are the same Caucasian race." When we look purely at the biological and genetic data, the deep divisions that are sometimes drawn culturally or politically, they simply don't exist on a molecular level. The science points to a profoundly unified, shared biological reality. Which leaves us with a final, provocative thought to ponder. If our bones, our tooth enamel, and our DNA unequivocally reveal a tangled, shared meshwork of global ancestry spanning tens of thousands of years, how does that rewrite the borders we draw today? What does it mean for modern identities when science proves we're all just distinct threads woven into the exact same human tapestry? It's a fascinating mystery that we're still unraveling. Thanks so much for joining me for this explainer, and keep learning.